Welcome back one more time for section 8, the axiomatic method. We want to just look at one more page of notes. So models and consistency. So if you've completed the activity, hopefully you've taken the opportunity to do that. The clips and strings in the activity, they themselves, right here you have this physical thing, they form a concrete model for the system of axioms, which shows that the collection of axioms is consistent. So there are no contradictions that are formed from the axioms. So we had the physical model, the concrete model with the string and the binder clips. And then we drew that on the sheet of paper. And that drawing forms an abstract model. Okay, it's an abstract model of the system, right? We replaced clips, physical clips, with just dots on the paper, and we replaced the strings with lines on the paper. If you wanted to find another concrete model, there are many ways that you could do this. You could do it by, as it says here, replace clips with people and strings with committees. That would provide another concrete model for the system. So this is an interesting statement here. So the flat planes and straight lines that you imagine and sketch when doing geometry form an abstract model of Euclidean geometry. Okay, so the plane, we have the plane, we're drawing in the plane. That plane is an abstract model of geometry, right? There's an infinite number of points. We can draw many different lines, points connected. So that's interesting. But we frequently think of this, the universe that we live in is a concrete model of Euclidean geometry. But is it? Is it really? There's many different ways that this can actually be questioned, and that's partly because we, for example, right, we frequently think about how things are flat on the Earth. Well, if we truly had Euclidean geometry on the Earth, then we would in fact have a flat Earth. But last time I checked, it's a sphere, or approximately a sphere. So unless you're a flat earther, then maybe you're on board with this Euclidean geometry being a good representation, or the Earth being a concrete model would be certainly true. But we don't live on a flat Earth. So that's one example, or one reason that one might say that Euclidean geometry is not a good model for, that the Earth is, that the universe we live in is not a good model for Euclidean geometry. But that's not the only thing by any means. Mostly this has to do with distance and how does distance change. For example, distance changes based on how fast you're moving. It's physics. I don't understand it, but it's there. So anyway, we don't know that Euclidean geometry is described by our universe. So a collection of axioms that do lead to a contradiction is called an inconsistent system. Inconsistent system. There we go. So let's take a look at a system that is inconsistent. Let's say there are a finite number of binder clips, and each string is connected to exactly 2 clips, and that exactly 1 clip is attached to an odd number of strings. What can we discover about this system? Well, we can discover that it's still really fun to draw these binder clips, first of all. I enjoy this. So here we have a binder clip, and let's we want to have a piece of string. It's got to be between two binder clips, so cool. But only right here we have both of these binder clips have an odd number of strings, right? 1. This binder clip is attached to 1. That binder clip is attached to 1. So this binder clip has to be attached to another string. Well, this string must be connected to another clip. Okay, fine. Let's draw another clip. So we get another clip on there, but now this one is odd, so it has to have another string, which has another clip, which has another string. But couldn't we bring that string all the way back to this guy? No, we could not, right? We couldn't attach this to here because as soon as we did that, now all of the binder clips have an even number of strings. But exactly one clip is attached to an odd number of strings. So, okay, well, let's add another binder clip then. Well, if we add another binder clip, we again have another string that we have to add. So this must go on forever. But can it go on forever? No, because there are a finite number of binder clips. So it must go on forever, but it can't. Right? We have a contradiction. This is inconsistent. All right. So all of the examples that we've taken a look at in this section are called finite geometries. All right, clips are points, strings are lines. Euclidean geometry has an infinite number of points and an infinite number of lines. All right, and that's it for the axiomatic method. So we'll pick up in section 9 the next time we get together. You guys have a wonderful day.